Ever wish you could like totally rewind on a mistake? And
Right.
I mean, really rewind, not just fix it, but make it like it never even happened.
Hmm. I think we've all been there.
Right. Well, get this. Today's deep dive, we're taking a look at quantum computing,
Oh, what?
where scientists are exploring exactly that, the possibility of reversing time.
Time reversal, huh?
Yeah. We're diving into an article. It's called Simulating Temporal Dynamics in Quantum Computing using Qiskit.
Interesting.
And let me tell you, this is a wild ride. It really like bends your brain a little bit.
It really does challenge how we usually think about time. You know, in our everyday world, time just marches forward, tick-tock, tick-tock.
Yeah.
But at the quantum level, things are a little more flexible.
So you're telling me like spilled milk could unspill itself?
Well, not exactly like that. But the idea is that in the right conditions, quantum systems can evolve as if time was running backward. It's what we call time symmetry.
Okay. I'm intrigued, but I need a little more. The article mentions this time reversal operator. What is that exactly? Is that like the key to this whole time-traveling magic show?
Well, you could think of it that way. Instead of all the complex math, imagine hitting Ctrl plus Z on your computer.
Undo.
Yes, it undoes a series of actions. The time reversal operator is kind of similar, but for quantum operations that you apply to a particle. So it basically lets us rewind that particle's evolution.
Okay, so we're not talking about like literally turning back time for the whole universe, more like hitting undo on specific particles.
That's it. And to do this, researchers are using a platform called Qiskit. Think of it as a really powerful simulator for building and experimenting with quantum circuits.
So they're using Qiskit to create these circuits that basically rewind how these particles behave. How does that even work?
It's actually pretty elegant. They start by defining the initial state of a quantum system. Then they apply these quantum gates, which are like instructions to control how the system evolves over time.
Okay, so far so good. And then,
Well, to get time reversal, they apply the inverse of those operations, but in reverse order.
oh, interesting.
It's like hitting undo on each step, but backward. And that creates a time reverse circuit that simulates the system going in reverse.
My brain is definitely doing some quantum acrobatics here, but I think I'm with you. Is there like a real world example of how they're testing this whole time reversal thing?
Yeah, the article talks about an experiment with a single qubit. You know, the basic unit of quantum information. Think of it as a quantum bit.
Gotcha.
So researchers set up the qubit, applied some operations to make it go forward in time, then used the time reversal sequence, and finally, they measured the qubit's state.
And drum roll, please. Did they actually rewind the qubit? Don't leave me hanging.
The results were impressive. The qubit went back to its initial state with really, really high fidelity, meaning the simulation worked.
Wow, so they actually did it. But okay, rewinding one single qubit, what's the big deal? Where does this lead us?
Well, that's where things get exciting. This seemingly simple experiment, it has the potential to change everything, from how we build quantum computers to our understanding of reality itself.
Okay, now you've really got my attention. Let's dive into those implications after a quick...
We can just jump right in, actually.
Even better. Tell me more.
One of the biggest challenges with quantum computers is that they are so fragile. Even the slightest thing can mess up a calculation. It's like,
Trying to write with a pen on a roller coaster.
exactly, one bump and your whole equation's ruined.
Yeah.
But now imagine being able to undo those errors. That's what time reversal could do for quantum computing.
So instead of trying to prevent errors, which sounds impossible with a system this delicate, we just hit undo on them.
That's the idea. If we can implement these time reversal protocols, we could make quantum computers much more reliable.
That's amazing. But what about beyond just fixing errors? Does this whole time manipulation thing have any other uses?
Absolutely. It could totally revolutionize how we design algorithms. Think about simulating, say, how proteins fold in a cell. Super complex.
Yeah.
It would take a regular computer years to do that. But a time-symmetric algorithm, using this rewind capability, that could find the most stable protein structure way faster. Huge implications for things like drug discovery. As someone in the field, you know how impactful that could be.
Huge. This is incredible. So we've got error correction and faster, more powerful algorithms. What else? The article also mentioned something about implications for fundamental physics. What did they mean by that?
Time, right? It's one of the most fundamental concepts in physics,
Yeah.
but also one of the most mysterious.
I mean, we all experience time passing, but what is it really?
Exactly. Our everyday experience tells us time goes in one direction. But as we see in the quantum world, it's not always so straightforward.
So by studying how time behaves in these quantum systems, we might actually understand its true nature better.
Exactly. This could even lead to changes in existing theories or even new physics beyond what we know now.
Wow. This has gone from rewinding qubits to potentially rewriting how we understand the universe. It's mind-blowing.
And we're just getting started. The research is still early, but it has immense promise.
So if I'm getting this right, this research could impact pretty much every field imaginable. Medicine, biology, computer science, physics. The possibilities are endless.
That's right. And it all comes back to this simple question.
Hmm.
What if we could reverse time in the quantum world?
It's a question with huge EE implications. Speaking of questions, I've got a big one for you and for our listeners to think about. So we can mess with time in the quantum world, but does that mean we can actually control our own destinies? If we can manipulate time at that level, what about free will?
That's a question that's been around forever.
Mhm.
Physicists and philosophers have been wrestling with that one for centuries.
Yeah.
And this research on time reversal in quantum systems is adding fuel to the fire.
I mean, we've all seen sci-fi movies where people travel through time, but is that even remotely possible in the real world?
It's a cool idea.
Hmm.
But taking what we see in the quantum realm and scaling it up to the macroscopic world, well, that's a whole other challenge. Remember, we're talking about manipulating individual particles here.
So rewinding a qubit is one thing, but rewinding a person or even a cup of coffee is something else entirely.
Exactly. The laws of physics, as we know them, dictate a clear direction of time for big objects. Think about entropy. Things tend to break down, get more disordered with time. That's why we age, coffee gets cold, and buildings crumble.
But you're not saying it's impossible that there might be more to the story of time than we currently get.
What's so exciting about this research is that it's pushing the boundaries of our knowledge. It's forcing us to rethink our assumptions about what time is and to explore new possibilities.
So while we might not be building time machines anytime soon, this research could lead to a fundamental shift in how we view time itself.
Absolutely, and that's the beauty of science, right? It's not just about finding answers. It's about asking better questions, broadening our horizons, and embracing the unknown.
Well said. And on that note, I think it's time to wrap up our deep dive into this mind-bending world of time reversal in quantum computing.
Yeah. But before we go, I want to leave you with one last thought.
Ooh, I love a good cliffhanger. Hit me with it.
If we can manipulate time in the quantum realm, it makes you wonder, what implications does that have for us understanding free will? If we can control how a quantum system evolves, could we, theoretically, control our own destinies?
Whoa, that's a big one. So we're not just questioning time itself, but now the very nature of choice and free will.
Exactly. It's a real philosophical rabbit hole, but one worth exploring.
Well, you've definitely given our listeners a lot to think about. It seems like figuring out the mysteries of time is far from over.
And that's what makes it so fascinating. Who knows what other mind-blowing discoveries are waiting for us as we keep exploring this uncharted territory.
This has been an incredible deep dive. To our listeners, thanks for joining us on this journey into the quantum realm. We hope this sparked your curiosity and gave you a sense of wonder about the universe and our place in it. Until next time, keep exploring, keep questioning, and never stop diving deep into the unknown, especially when it comes to something as slippery as time. So we're talking about controlling how a quantum system evolves. But could we actually control our own destinies? If we can manipulate time at the quantum level, what does that mean for free will?
It's a really deep question. It takes us into philosophy. It makes us think about that old debate, determinism versus free will.
Right. It's like that thought experiment. What if you knew everything about the universe, every single particle, every motion?
Right.
Could you predict the future? And if you could, does that mean we don't actually have free will?
Exactly. And being able to manipulate time and quantum systems, that adds a whole other layer to this debate. If we can control how a quantum system evolves, does that mean there's some level of predetermination? Or is it just giving us a new tool to influence things?
It's a lot to wrap your head around. So for our listener, what's the takeaway here? What should they be thinking about as we finish up this deep dive?
I think the main thing is this research on time reversal in quantum computing. It's not just about some technological advances. It's about challenging what we think we know about reality, about time itself, and even about our own role in the universe.
It really makes you realize that the universe is way more strange and amazing than we often give it credit for. And trying to understand it, it's a journey that's always full of surprises.
I agree. And who knows, maybe this research will one day give us answers to some of humanity's biggest questions.
That's a pretty amazing thought. To our listeners, thank you so much for joining us on this deep dive into the mind blowing world of time reversal and quantum computing. We hope this sparked your curiosity and left you with a sense of wonder about the mysteries of the universe and our place in it. Until next time, keep exploring, keep questioning, and never stop diving deep into the unknown.